Hello, Math 100. I got a couple of questions I want to go over from the homework about rational exponents. They throw out all kinds of problems in that homework section, so I want to make sure you feel comfortable with this. So one of the first ones I want to look at happened to be number 9 for me, but it could show up as any number, right, with positive exponents. Simplify if possible. Assume that all variables represent positive real numbers. Now, a couple of things about the directions. Write with positive exponents. Right now, you notice what we have is we have a negative exponent, and it's a fraction. They don't need us to change that from a fraction, so we can leave it as a fractional exponent, which is also called a rational exponent. The reason it says assume all variables represent positive numbers, remember when you take square roots or fourth roots or sixth roots, you cannot evaluate the square root or any even root of a negative number. So that's why they have to throw out these extra bit of directions, but it's not going to change how we do the problem, okay? So way back in chapter 12, we were asked to deal with negative exponents. Remember the definition of a negative exponent. I'm not working on this problem, just a definition, is that if you have, for instance, x to the negative 3 power, that's equivalent to 1 over x to the third. Or if you have 1 over x to the negative 5th power, you can take that to the numerator. Now the 1 would stay, and that would be x to the positive 5 power, which would give us 1 times x to the 5th is x to the 5th. So what's really happening, notice this, is every time you have a negative exponent, you take it to the other side of the fraction bar. So if it's in the numerator, notice we took it to the denominator. If the negative exponent's in the denominator, whoop, you shoot it back up to the numerator. All right, so we've got that. Now, I'm going to erase here. Bear with me. Okay, I don't want to create any page. Just pretend like it's a big giant board and I'm erasing it. Okay, so here we go. Now, I'm dealing with this particular problem. I'm going to even erase my highlight so I can highlight something different. Okay, so what's the negative exponent? That applies to just the, it's so tiny, that it applies just to the x to the negative 4. The 1/8 must stay. So when I work on this problem, I have a fraction and the 1/8 is already there. Now the highlighted x to the negative 3/4, I'm going to take that to the top and I'm going to make that x to the positive 3/4 power. So I've done it, right? I've made my negative exponent positive by taking just the negative exponent and its base to the other side of the fraction bar. Now it does say simplify if possible, and if I multiply 1 times x to the 3/4, that would just give me x to the 3/4 power over 8. And that would be as simplified as possible. Now I have a second problem here for you that it's a lot, right? It's a lot going on. So again, I want you to reflect back to your properties that you learned for exponents in chapter 12 when we talked about properties of exponents. Remember what you have when you have first of all, let me back up. This 1/6 exponent that I've got going on right here, my question is, what does that apply to? Well, notice I've got parentheses around this x to the 3rd y squared, so it applies to all of it, right? Well, anytime you are multiplying, you can apply that exponent to both of these values inside. Now, if you were adding, you couldn't split this up like we're about to do, but because we're multiplying, you can say that that 1/6 applies to the x to the 3rd, and that 1/6 applies to the y squared. So notice I put that 1/6 outside of each one of those. Same things happening in the denominator, right? That negative 1/3 exponent, it applies to both of those values inside because we're multiplying. So I'm going to say this x to the negative 5 can be raised to the negative 1/3 power, and this y to the negative 1 can also be raised to the negative 1/3 power. And when you simplify exponential problems, you may remember this way back from our very first module, that the order that you do this in can vary. Like I might do it differently than you are thinking, but I can tell you that it's probably easiest to go ahead and handle that 1/6 and that negative 1/3 to both of those values inside first. Also not required, but I think it's easier. Now, what's the next thing we should do? Well, I've got a power raised to a power, right? What am I talking about? Right here. I've got a 1/3 raised to a 1/6, and I've got another one here, a 2 raised to a 1/6, and then another one down here, -5 raised to the negative 1/3, and then this -1 raised to the negative 1/3. I have to multiply those. Remember that rule? So I'm going to multiply x, and it's going to be 3 times 1/6, and then it's going to be y, and then 2 times 1/6, and in the denominator, you're going to have x, and then up here I'm going to have -5 times negative 1/3, and then y, and then -1 times negative 1/3. Correct? Now, most of you probably just do that in your head. I wrote it out so you can clearly see what we're doing here. Now, when I multiply 3 times 1/6, that's 1/2. So that's going to give me x to the 1/2 power. And then 2 times 1/6, that gives me 2/6, which is 1/3. Y'all can do that in your head, right? Okay. Denominator, -5 times negative 1/3 is going to be x to the 5/3. And then right here, -1 times negative 1/3 is y to the positive 1/3. Now, I'm not finished. Right? Why? Because I have x's in both the numerator and the denominator, so I can simplify. Now, one thing you might have noticed, hey, check it out, y to the 1/3 and y to the 1/3 cancel out because they're exactly the same base and exponent. So they really divide out, they're called common factors. You cancel common factors, and that would just give us 1, except we still have an x to the 1/2 and an x to the 5/3. Now back to your, I know you're tired of me saying this, but what about those exponent rules from Module 1 or Chapter 12? What can you do when you divide the same base? What do you do with the exponents? Yes, you subtract. So this is going to be x to the 1/2 minus 5/3. Now, if you got a fancy fraction button on your calculator, you could just type in 1/2 minus 5/3 and it'll tell you the answer. But we want to do everything by hand around here, right? So I need a common denominator. I can't subtract these fractions without a common denominator, which is 6. So this 5/3 I'm going to multiply by 2 over 2. This 1/2 I'm going to multiply by 3 over 3. And that's going to give me x. Now this is going to be 3/6 minus 10/6, okay, which is going to be x to the, now 3/6 minus 10/6 is going to be -7/6. Yuck, right? Okay, now I'm going to go back and read the directions because I don't know how to write my final answer. Notice it says write with positive exponents, assume that all variables represent positive numbers. So if I write this thing with positive exponents, I can't leave it as x to the -7/6, not x. Whew, glad I caught that. There we go. Okay, so that means it belongs on the other side of the fraction bar. That would be 1 over x to the positive 7/6. And that is with positive exponents. So we use properties of exponents that we learned in Module 1 or Chapter 12. We wrote it with positive exponents. Again, we assumed all the variables were positive in case we were taking the even root of a negative number, and we can't have that, right? So this should be the final answer there. I hope this helps. If you have any more questions, send them to me. I hope you have a wonderful day.